All right, so let's get into part 2 of the lectures we have for Friday. And our first topic here is the opposite of the topic we just ended on, and that's electron affinity. So we just talked about ionization energy, which is the energy to remove an electron. Electron affinity is the energy you get when you add an electron. And here are some general things about electron affinity. Now, our trends aren't as nice and neat as ionization energy, but in general, as you go down the column, the electron affinity decreases. And this is kind of weird, right? Because we're talking about negative. So negative energies are good. You want negative energy. So reading this, if we look at helium, we have a negative 73. Rubidium has a negative 47, which means helium wants the electron more. You get more energy out. And so as you go down, it generally decreases. As you go across, it generally increases, with some notable exceptions. Group 2A like never wants an electron. Right? So their electron affinities are positive or barely negative. The reason for this, if we look at beryllium, 1s2, 2s2, to put an electron in, you would have to open up a whole new orbital, the 2p orbital, and you really don't want to do that. So you want to lose electrons. So the 2a, the electron affinities are really bad. 5a, the electron affinities are generally bad because you have to pair. So let's look at that. So nitrogen is 1s2, 2s2, 2p3. Let's look at our p orbitals. Remember, for p, L is 1. So m's of L has 3 values, -1, 0, or +1. So we get 3 dashes. Normally, for nitrogen, each electron is unpaired, which is good. But if we gain another electron, we have to pair up electrons. And nitrogen really doesn't want to do that if it can help it. So nitrogen electron affinity is positive. So nitrogen is usually always a cation in reactions because of that. So group 5A is lower than what you expect. Groups 8 will never want an electron because they are full octet already, right? They don't want an electron. You can't take an electron away from them easily. They're good. They're neutral. And who wants electron the baddest, or the most energy you get out, are the halogens, because they're 1 electron away from being a noble gas. So they have a very, very negative electron affinity. So in general, as you go down the periodic table, electron affinities become worse. As you go across, they become better. But there are a lot of exceptions to this. So from our trends that we just talked about, I want you to tell me what is more negative electron affinity. Again, pause this video, see if you can figure it out, and then unpause when you got them. But I'm just going to go through them right now. So Na versus Rb. So same column, Na is further up, so it's going to have more negative. Boron versus sulfur. Sulfur is to the right. True that sulfur is below boron, but sulfur is more to the right, so it's going to be more negative. Carbon versus nitrogen. Nitrogens are oddball. Nitrogen does not want electrons, so carbon wins by default. Lithium or fluoride. Fluoride's a halogen. Halogens really want electrons, so halogens will win. And magnesium versus sulfur. Sulfur is to the right of magnesium. Magnesium does not want an electron at all because it's in the second column. So sulfur is more negative. And the last thing we're going to talk about here is trends in metallic character of atoms. And we talked about this way back in the beginning of the semester where we looked at the 3 types of atoms you have. You have metal atoms, you have non-metal atoms, you have metalloids. And remember, metals are on the left, non-metals on the right. So in general, as you go down a periodic table and to the left, you become more metallic. So francium is our most metallic atom. Helium is our least metallic atom. And hydrogen is a nonmetal as well. So even though it's right here, it behaves like a nonmetal. So just remember that trend. Bottom left, most metal. Top right, least metal. So again, let's try and answer these. So pause, answer them, and come back. Make sure you have your periodic table out. So let's see which one's more metallic. SR versus SB. So SR is to the left of SB. So SR is more metallic. AS versus BI. BI is further down the periodic table than AS, so it's BI. S versus AS, sulfur versus arsenic. Arsenic is to the bottom left of sulfur, so it's arsenic. Then SB versus PB. So PB is lead, and SB is antimony. Lead is to the bottom left of antimony, so it's lead. So that's all. You're seeing what's to the, remember, the bottom left, it's the most metallic, so you're just looking for that. And we're going to skip how to predict reactions with alkali metals and with water and halogens. So yeah, don't worry about this for test 4. But that ends our 2-part PowerPoint really quick. And we're caught up to where we should be on Monday. So I'll be back live for you on Monday. Again, if you have questions, let me know. I'll answer those on Sunday. Oops. Otherwise, I hopefully will see you Monday. Have a good weekend, everybody.